Hi friends, welcome to the presentation. In front of you, I am 𝗘𝗽𝗍 𝗧𝗏 studying in 10th standard at TTWREIS Girls Mahbubnagar. Today, I want to tell you an interesting topic in the physics. It will be very interesting till the end and it will be continue. We all know that many children like stories. That's why I will start my concept with a small story. Once upon a time, there was a family. Ramu and his family living very happily. One day, Ramu's mother went to the vegetable market to purchase the vegetables. On that time, Ramu and his father spent their time in the home. Ramu's father wished to watch India's World Cup match on the television. That's why he sat on the sofa and watching the match very interestingly. Suddenly, he got a noise from the kitchen. He went to the kitchen. There, he observed that Ramu doing many naughty things. That's why Ramu's father said that, Ramu, if you didn't did any naughty things for today, then I will purchase a gift for you tomorrow. Ramu agreed this and without doing any naughty things, he silently went to his room and slept. And the day came. Ramu's father entered into the Ramu's room and said, Ramu, get up. Did you remember that? Yesterday night, I promised you that I will purchase a gift for you. Then Ramu told that, yes, Papa, I remember this, but I have a doubt. Doubt? What is your doubt, Ramu? Yesterday night, you told that you will purchase a gift for me. That's why I waited a lot of time. And the day came. My doubt is how this day and night are formed. I can't understand. Can you explain me, Papa? Then Ramu's father replied that, very good question, Ramu. Our earth rotates and revolves around the sun. Our earth rotates and revolves around the sun. By that we get day and night and season. It always happens due to the motion of the earth around the sun. Motion? What is meant by motion? Today our interesting topic is also about the motion. Before going into the topic, we want to know what are the today's objectives. Our today's objectives are motion, rest, uniform motion, non-uniform motion, types of motion, and daily life applications. Hello friends, what do you know about the motion? How to define it from the story? Motion is a common experience in our daily life. We may observe that birds flying in the air and vehicles traveling on the road, train traveling on the railway track. These are also the example for the motion. Motion. What is meant by motion? Motion is nothing but when an object changes its position from one point to the another point, then the object is said to be motion. Motion is nothing but when an object changes its position with respect to the time, then the object is said to be motion. On the screen, we observe that a car moves from point A to the point B. It means it changes its position over the time. We say that it is the example for the motion. Now here I have a toy. When I apply some force on this toy changes its position from one point to the another point. It means it is the example for the motion. Now you have understand about the motion. Now we want to know the second type of the objective is rest. Moreover, we may observe many objects in our surrounding like windows, cars, bags, books, etc. When you observe those things does not change their position. Does not change their position from one point to the another point because they are the examples for the rest. Rest. What is meant by rest? Rest is nothing but when an object changes its position does not change its position from one point to the another point is known as rest. Rest is nothing but when an object does not change its position with respect to the time, then the object is said to be rest. On the screen, we observe that a tree, house, and table. When you observe those things, they does not change their position. They does not change their position because they are the examples for the rest. Now here I have a bottle. When I kept this bottle on the table, let us observe it for 10 seconds. When we observe the bottle as the time goes, but there is no change in the position of the object, because the bottle is present in the state of rest, Rest, what is rest? Rest is nothing but when an object does not change its position respect to the time, then the object is said to be rest. We also have the examples are tree, house, table, and also the position of the bottle. Now, you got clear information about what is meant by rest and what is meant by motion. Motion is nothing but when an object changes its position respect to the time, then the object is said to be motion. Rest is nothing but when the object does not change its position respect to the time, then the object is said to be rest. You got information about rest and the motion. Now we have raised a question. Is there any relation in between the motion and the rest? For that, we have an activity. We know that science has many activities, and also we are feel happy to see the activities. Now, I have the activity it is my hand. What is your observation, friends? Yes, exactly. Your observation is my hand is left side for you, but my observation is my hand is right side for me. Here the only one hand looks like left side and also the right side. These are known as relative terms. Here the relative terms are left and the right. To understand the relations, we have the another example is, if we think it is 3 floors of building, it is first floor, it is second floor, and it is third floor. When the first floor person observes the second floor person, he looks like upside to the first floor person. And the same person who was observed by the first floor person now observing by the second floor person. When the third floor person observes the second floor person, he looks like downside to the third floor person. Here the only one person, second person, looks like upside to the first floor person and downside to the third floor person. Here the relative terms are up and down. Now we got information about the relative terms of left and right and also the up and down. Now we want to know the relative terms in between the motion and the rest. To know the information, imagine that you are in a traveling bus. When you are in a traveling bus, yourself you are in the rest. Because you does not change your position over the time. But at the same time, you are in the motion. Who was observing you from outside of the bus? You are the only one person looks like rest and also the motion. Here the relative terms are motion and rest. How to define the relative terms of motion and the rest, friends? Yes, exactly. What is meant by relative terms of motion and the rest is nothing but if a body looks like rest in one set of surrounding and the same body looks like motion in another set of surrounding is called relative terms in between the motion and the rest. Let us repeat the definition. What is meant by relative terms in between the motion and the rest is nothing but if a body looks like motion in one set of surrounding and the same body looks like rest in another set of surrounding is called relative terms in between the motion and the rest. Now we have completed the topic about the what is motion and what is rest. Now let us move to the uniform motion. Before going into the uniform motion, I want to tell you the one thing is sometimes we may use the word is I am too early. Sometimes we may use the word is I am too late. How to say you are too late and too early? Exactly. Depends upon the time we say that I am too early and too late. There is no work is going on without the clock on the wall and watch on the hand. Today our example is also the clock. When you observe the hands of the clock, we have the question is, does the hands of the clock covers the equal distance in equal time of intervals? Does the hands of the clock cover the equal distance in equal time of the intervals? Yes, the hands of the clock cover the equal distance in equal time of intervals. We say that it is an example for the uniform motion. Uniform motion? What is uniform motion? Uniform motion is nothing but if a body covers equal distance in equal time of intervals, then it is called as uniform motion. We have the another example for uniform motion is rotation of the earth. When you observe the rotation of the earth, it also covers the equal distance in equal time of the intervals. But we don't observe the rotation of the earth, isn't it? Yes. Then how to say the rotation of the earth is also covers the equal distance in equal time of intervals? Yes. How to say the earth covers equal distance in equal time of intervals is nothing but every day we get 24 hours in a day and 365 days in a year. Hence, we say that the rotation of the earth is also covers the equal distance in equal time of intervals. We have the another example for the uniform motion is rotation of the fan. When you observe the rotation of the fan, it also covers the equal distance in equal time of intervals. It also covers the equal distance in equal time of the intervals. We say that is the example for the uniform motion. We observe the clock, earth and fan on the screen because they are the example for the uniform motion. Uniform motion is nothing but if a body covers equal distance in equal time of the intervals, it is called as uniform motion. Now you have understood about the uniform motion. Now let us move to the non-uniform motion. Before going to discuss non-uniform motion, imagine that you are in a garden. Imagine that you are in a garden. When you are sitting in a garden, we love butterflies. Yes, when we observe the butterflies, we have the question is, does the butterfly covers the equal distance in equal time of intervals? No, the butterfly does not cover the equal distance in equal time of intervals. We say that is the example for the non-uniform motion. Non-uniform motion? What is non-uniform motion? Non-uniform motion is nothing but if a body covers unequal distance in equal time of intervals is called non-uniform motion. On the screen, we observe that butterflies, running horse and transball. These are the examples for the non-uniform motion. If we take the another example for the non-uniform motion, when you observe the horse running, it also covers the unequal distance in equal time of intervals. In round 1, it may take 5 minutes to cover the 85 meters. In round 2, it may take 5 minutes to cover the 90 meters. In round 3, it may take 5 minutes to cover the 100 meters. We say that non-uniform motion is nothing but if a body covers unequal distance in equal time of the intervals is called non-uniform motion. We also observe the transball on the screen. It is also the example for the non-uniform motion because it also does not cover the equal distance in equal time of the intervals. You have understand about the uniform motion, non-uniform motion. But to understand the clear information about the uniform motion and non-uniform motion, we have the another representation is graph representation. When you observe the graph A shows that example for the uniform motion. How to say it is the uniform motion is nothing but x-axis has time in minutes and y-axis has distance in meters. In 1 minute it covers 10 meters, in 2 minutes it covers 20 meters, in 3 minutes it covers 30 meters. Hence we say that it is covering equal distance in equal time of intervals. It is covering equal distance in equal time of intervals. We say that is the example for the uniform motion. When you observe the graph of the non-uniform motion, it covers the 5 meters in 1 minute and 10 meters in 2 minutes and 20 meters in 3 minutes and 25 meters in 4 minutes. We say that here the body is covering unequal distance in equal time of the intervals. These two graphs are the example for the uniform motion and non-uniform motion. I think you have understand the concept of uniform motion and non-uniform motion. Now let us move to the another objective is types of motion. Before going to the types of motion, we have some situations. The situation 1 is a car traveling along a straight road, and the situation 2 is motion of a blades of a ceiling fan, and the situation 3 is movement of needle of a running sewing machine, and the situation 4 is motion of an pendulum clock. Based on the path taken by the bodies, the types of motions are further classified into three types. The first one is translatory motion, the second one is rotatory motion, and the third one is oscillatory motion. Shall we repeat, friends? Yes, the first one is translatory motion, the second one is rotatory motion, and the third one is oscillatory motion. Now, we want to discuss about the first type of the motion is translatory motion. On the screen, you observe that a bus traveling from a point A to point B. Bus traveling from a point A to point B. Here the point A is tree and the point B is pole. Now we have the question is, when the bus traveling from a point A to point B, we have the question is, does bus carries all the parts like wheels, seats, windows along with the bus from point A to B? Yes, the bus carries all the parts. Here we observe that a car carries all the parts. Here the point A is tree and the point B is pole. When we observe this, just observe this. Point A tree to point B pole. It means it carries all the parts like wheel, seat, windows along with the car from point A tree to point B pole. It means it is the example for the translatory motion. Now, this translatory motion is also further divided into two types. The first one is rectilinear motion and the second one is curvilinear motion. Coming to the rectilinear motion, in our daily life, we may observe that some vehicles going in a straight path and some vehicles taking curved path. The vehicles which are going in a straight path are the examples for the rectilinear motion, and the vehicles which are going in a curved path are the examples for the curvilinear motion. Here we say that rectilinear motion is nothing but if a body moves in a straight path, and translatory motion is called rectilinear motion, and the curvilinear motion is nothing but if a body moves in a curved path and translatory motion, then it is called as curvilinear motion. On the screen, we observe that a car traveling on a straight path and a car traveling in a curved path. We say that they are the examples for the rectilinear motion and the curvilinear motion. Now let us move to the next topic is rotatory motion. Just observe the pictures on the screen. When you observe the pictures on the screen, we observe that a spinner, wheel and a joint wheel. When you observe those things, we say that they follows the circular path with unfixed center of axis. They are the examples for the rotatory motion. What is rotatory motion? Rotatory motion is nothing but all the parts of a moving body follow a circular path with respect to a fixed center of axis. With respect to a fixed center of axis is known as rotatory motion. Here we have the example for the rotatory motion is spinner. When you observe the spinner, it follows the circular path with unfixed center of axis. We say that the spinner is an example for the rotatory motion. Now we have observed about the rotatory motion. Rotatory motion is nothing but all the parts of a moving body follow a circular path with unfixed center of axis is known as rotatory motion. You also observe the images on the screen as spinner, wheel, joint wheel. They are also the examples for the rotatory motion. We have the another example for the rotatory motion is here we observe the fan. When you observe the fan, it also follows the circular path with unfixed center of axis. We see that it is also the example for the rotatory motion. Now itself you have observed the fan. The fan follows the circular path with an fixed center of axis. We say that it is an example for the rotatory motion. Now you have got information what is meant by translatory motion and rotatory motion. Translatory motion is nothing but all the parts of a moving body move in the direction of the motion, then it is called as translatory motion. And rotatory motion is nothing but all the parts of a moving body follows the circular path with an fixed center of axis is known as rotatory motion. Now you have got information about the rotatory motion and also the translatory motion. Now I will tell you the example. You want to guess which type of motion is it. Now here I have a ball. When I apply some force on this ball, it means when I push the ball, here we observe that the ball changes its position from one point to the another point. We say that the ball is present in the motion. But we have the question is, which type of motion does the ball follows? Here we observe the ball carries all the parts along with the ball from point E to point B. It means we say that it is present in the translatory motion. At the same time, we also observe that ball follows the circular path with an fixed center of axis. We say that it is also the example for the rotatory motion. Now we have the doubt is, the ball is in the translatory motion or the rotatory motion? Yes, the answer is the ball possesses both the translatory motion and rotatory motion. Not only this, we may also observe many things in our surroundings which possess both the translatory motion and the rotatory motion. To understand this, I want to tell you the another example is, let us take a car. Now here I have a car. When we observe the motion of the car, we observe that the motion of the wheels. When you observe the motion of the wheels, we say that it carries all the parts. We say that it is in the translatory motion, as well as we also say that the car contains the wheels follow the circular path. We say that it is in the translatory motion. Here the car contains the wheel also follow the translatory motion and also the rotatory motion. Not only this, you may also observe many things, many objects which possess both the translatory motion and the rotatory motion. Today, your homework is observe your surroundings. The object which possess both the translatory motion and the rotatory motion are the examples for the rotatory motion. Now let us move to the third type of the motion is oscillatory motion. In our day-to-day life, we observe the movement of the needle. When you observe the movement of the needle, it moves up and down. It means it is the example for the oscillatory motion. How to say it is the example for the oscillatory motion? The to and fro motion of an object follows the same path about a fixed point is known as oscillatory motion. Here we have the example is, when you observe this, it follows to and fro motion. To and fro motion is nothing but up and down or side to side movements are known as to and fro motion. On the screen, we also observe that a girl swings and the movement of the needle and a pendulum clock are also the example for the oscillatory motion because they follows the to and fro motion about a fixed point and follow the same path. We say that they are the example for the oscillatory motion. Before going to conclude my topic, I want to give you an assessment. Assessment is, write an essay on how the motion played an important role compared to ancient time till now. Today, my conclusion is, without the motion of the object, we can't do anything. For example, when we think about the transportation, drag change is there compared to ancient time to till now. After that, in olden days, people choose their path, food to change their objects from one point to the another point. After that, many discoveries are occur like steam engine, water bodies, aeroplanes, etc. Whatever the transportation is there, like water transportation, land transportation, air transportation, All these are depends upon the motion of the object. Finally, I want to say one thing is some desires are necessary to keep life in motion. Some desires are necessary to keep life in motion. Now, first of all, I thank to our Secretary Sir Naveen Nicholas Sir and our RCO of Mahbubnagar region Nagarjuna Rao Sir Garu, and I want to thank our respected Principal Madam Rajini Ragalata Madam to giving this opportunity, and also I want to say special thanks to my mentor teacher P. Avanti Madam. Last but not least, I want to say thanks to my parents, sisters, friends supporting me, and finally I thank TSAT and TSAT team. Thank you.